Hello everyone. I would like to do two examples using our sum to product identities. So we already looked at the product to sum where we're able to take multiplication of a couple trig functions and turn that into addition or subtraction. Here we're going to go the other direction. So I want to be able to take a couple trig functions that are being added or subtracted and then change that into multiplication. So in the first example, we're just going to do some rewriting. And as we've seen before, these identities is going to give us a way where we can go from angles that aren't on the unit circle and then give us something that hopefully is. So in this first example, we should be able to find the exact value. And then in the second example here, I want to use an identity to help me solve an equation. Okay. So here we have two cosines. They're being subtracted. So our identity for this, I'll just jot it over here on the side. So the identity is -2, and then it's the sine of the two angles added together divided by 2 times the sine of the two angles subtracted divided by 2. All right, so kind of thinking about this, much like we saw with our product to sum, these angles that we have here, these aren't ones that are normally on the unit circle, but if I add or subtract them, maybe that will give me something that is. So using our identity, this is equal to -2, and then the sine, and then we add the two angles together. So 7 pi over 12 plus pi over 12, and that's all over 2. And then times the sine of our two angles subtracted. 7 pi over 12 minus pi over 12. Okay. So now we just have to simplify these fractions a little bit. This is all going to work out pretty nice. So let's see what we end up with. So 7 over 12, and then this is 1 over 12. That's going to be 8 over 12, and 8 over 12 simplifies to 2/3. So this is 2 pi over 3, and that's still going to be over 2. And then our second one here, 7 over 12 minus 1 over 12 is 6 over 12, and 6 over 12 simplifies to 1/2. All right, to finish simplifying, 2/3 divided by 2 is the same as 1/3, so you get the sine of pi over 3, and then pi over 2 divided by 2 is pi over 4. That all works out really nice because pi over 3 and pi over 4, those are both angles that are on our unit circle. So we can figure out our value here. So the sine of pi over 3, the y value of pi over 3, that is the square root of 3 over 2. And then the sine of pi over 4 is the square root of 2 over 2. Okay, and to finish this up, just doing our multiplication. So square root of 3 times the square root of 2, multiplying the radicands together, that's the square root of 6. One of these 2's will simplify to 1. So this is over just 2, and then we do have the negative. So negative square root of 6 over 2. So again, the identity, it's a nice way. These angles are not ones that are on the unit circle, but using the identity, we do end up with some trig functions that deal with angles that we can find out. All right, and now let's use that idea for solving an equation. The really nice thing about these identities is because we're turning it into multiplication, we're going from a sum, or in this case a difference, and we're changing it into multiplying. that means we can apply our zero product property right away. And this is equal to 0. So we have a couple cosines being subtracted. Let's change this into multiplication. And it's actually the same identity as the one up here. So using our identity, this is going to be -2, and then sine of the two angles added together. So the sine of 3x plus 5x times the sine, and then the 2 subtracted, 3x minus 5x. Okay, let's do a little bit of simplifying, make it easier to work with. 3 and 5, this is the sine of 8x, and then 3 minus 5 is -2. So now we end up with -2 times the sine of 4x times the sine of -x. And as I said, these are being multiplied together. Okay, so one thing we can do is we have a -2 here, so we can divide both sides by -2. 0 divided by -2, that just stays as 0. So the sine of 4x times the sine of -x is equal to 0. And as I said, the nice thing about this is now we have multiplication. So this is basically like it's in factored form. So we can separate this into two different equations. So we have one, the sine of 4x is equal to 0, and then the sine of -x is equal to 0. Okay, so now we just need to solve both of these. So for this first one, we're looking for when is sine 0. And let's just start by taking a look at our interval from 0 to 2 pi. That will give us our first couple answers, and then we can use our period to get the rest of them. So sine is 0 at 0, so 4x is 0, or the other time that sine is 0 is at pi. So then that means x is equal to 0 or pi over 4, just dividing both of those by 4. Here, sine of -x, so maybe we haven't seen it written like this before, but we know that sine is an odd function. So the sine of -x, that is the same as the opposite of the sine of x. So that negative, we can divide by -1, so it's just when is sine of x equal to 0. So in this case, when is sine 0? That's going to be at 0 again, or at pi. All right, we do have a little bit of a repeat here. But now let's use the periods to get all of our possible answers. So x is equal to, and then let's see, so over here, the sine of 4x, the period for this one, so we take 2 pi divided by 4, so the period of this is pi over 2. So starting at 0, and then if I add multiples of pi over 2, that would give me all possibilities for that. And that does actually take care of the pi here as well, because pi is a multiple of pi over 2. And then we also want to do pi over 4 from here, plus our multiples of pi over 2. And that should take care of all of our possibilities. And then let's just state, so we want to make sure that where n is an element of the integers. And there's all of our possibilities.